Hey everyone, welcome to the podcast. I've got KIOXIA with us today talking about all things Flash, and probably couldn't be more timely with huge expansion in AI and other modern workloads. Thanks for getting in on the podcast. We're going to get to AI, but I want to start with some other things first. First of all, tell us a little about what you do at KIOXIA and who you are.
Thank you, Brian. Thank you for having me. My name is Maulik Sompura. I lead the product management team of SSDs at KIOXIA Americas.
And that is a bigger and bigger job these days. I mean, in the early days of Flash, you had a couple models, and now the portfolio is unbelievably diverse. Like, what when you think about managing SSDs, like, what's the hardest part with such a big portfolio these days?
That's a great question. Um, just the complexity of very fast-paced, rapid changes happening, especially with the AI boom. We are in a great time right now. Honestly, storage is at the forefront after, if you think about GPUs and HBMs. So it's a great place to be. However, as you said, the complexity is growing immensely, and especially on the enterprise side, with hyperscalers specific requirements, very custom requirements for their own needs. And they are obviously huge customers, so they demand certain things specifically for themselves. The form factors are growing like crazy, so we have so many form factors coming in, especially with higher capacities. And now you see the liquid cooling coming in with Gen 6. So there are new changes happening for liquid cooling. In terms of performance, the GPUs are pushing the performance boundaries like anything we've seen before. And we are growing at an unprecedented pace. So yes, it's a very challenging landscape right now.
So we are just coming off OCP. I didn't make it out there this year, but you're talking about hyperscalers, and it seems to me that historically the hyperscalers have really dominated the direction of storage, if that makes
Mhm.
sense. And I don't know that everyone really understands that. The Metas of the world and Google and Amazon and all of these guys will say, this is what we want out of a drive. Go build us a couple million of them, and then that really drives the direction for enterprise.
Yeah.
Talk a little bit about maybe some of the benefits that the enterprise derives by hyperscalers sort of driving the performance and the form factors and whatever else you think is relevant there.
Yeah. So yes, I was there at the OCP event this year. It has significantly grown. And now I see that event, it's like we are talking about very detailed storage stuff from all the way to data center, even real estate, right? And it has grown significantly in terms of data center infrastructure. So I think one of the key things is the OCP specification itself. When the hyperscaler started, then OEMs joined. The OCP specification is kind of honing everybody in one direction, and it's simplifying at least all the stuff that we used to do in silos. And there were lots of changes which firmware had to accommodate, and we had to validate. So now having one specification on top of the NVMe specification helps a great deal, even to the enterprise customers.
Hmm.
There are minor changes. Enterprise customers specifically, they sell from point of sale all the way to the data center, so their requirements still could be much bigger in that scope. They have to kind of address a single customer versus a gigantic, small customer compared to a CSP. So in that regards, there might be changes. They do require certain stuff that, for example, 3 drive writes per day, you know, is one example, right? So what those things are different, but otherwise it does help overall to get into the same space from specification. And I think as an industry, it's coming together even for form factors. As I said, while there are, it's this wide gamut of form factors. I think industry is coming together slowly to kind of reduce that. Everybody's worried about the increased number of SKUs.
Well, yeah, I mean, you hit on a couple things. You hit on performance. That could be a couple level of SKUs. You hit on form factors. That could be, I mean, at this point, a dozen different form factors that when we start factoring in all the EDSFF variations and the thicknesses, Z height. Uh, and then you've got endurance, which you didn't get to yet, but I'm sure we will, which is another factor. And as you slide all those knobs around, you could end up with a difficult portfolio to wrangle with too many options. But it sounds like if you feel like at least, I mean, in the enterprise, I think we've seen it already, right?
Yeah.
We still have a little bit of U.2 hanging around, but uh, E3S seems like the way most modern servers and then eventually storage appliances will go to. Uh, I'm sure that's consistent with what you're seeing, but what else are you seeing in terms of thinning down the varieties of form factors?
Yeah, that's always a question. In fact, I'm going to Japan next week, and that's one of the discussions, right? Internally, of
Mhm.
course, we are talking to the external customers for all of these, but we have Even.L, we have different varieties of Even.S. Now, Liquid Cool is joining that. E3S, 1T, 2T. So far, 2T, very few, almost non-existent.
Mhm.
And then we have 2.5 inch, as you mentioned. So 2.5 inch will still continue, but Gen 6, as you said, people are moving to E3S 1T. And I think that's the right direction in terms of power and thermals. That's where we are making progress, and we are recommending customers to kind of move toward E3S to align as an industry. And so we are semi-successful, I would say. There's a lot of legacy stuff, and people still want certain things. And plus, these things run very long here, right? So people have to support for 5 years, 7 years. So yeah, I'm hoping that by Gen 6 and Gen 7, we kind of come to a much smaller number of form factors and SKUs
Well,
as we go forward.
yeah, I know. It's funny though. As soon as you say that, I mean, we were just writing not long ago about E2, which is
Yes.
another one, which is unbelievable. And if
Yes.
for people that don't know, this is a much larger physical
Yes.
SSD, really designed for capacity. And I don't know that it's in the mission, but I think of it as maybe the true hard drive replacement form factor and capacity and performance profile. But was that a popular topic at OCP this year?
Yes, yes, there were a couple of discussions on E2, and the way they design E2 is very clever. So we are using the same connector, same height as E3. It's just that instead of E3L, it's longer, but it also is slightly thicker. So when you look at like front-mounted SSDs, it's basically you can't use the same slots that you build for E3S because this is now 9.5 millimeter thick instead of 7 point. And therefore you still have to design design a different chassis to take advantage of that, and it's longer. So if you have components in the backside, you have to shift everything. um, s- you know but it does allow you to reach to huge capacities. So in the future, if we have 4 terabit die, for example, or and you can go much higher in stacks, then you can go up to 1 petabyte just on a drive.
That's amazing. I mean, we saw we saw some people concerned about things like blast radius and rebuild and whatever as we went from even just 4 to 8 terabytes and 8 to
Oh,
16 and now that 122 has been shipping for a while. You guys have announced a 245
yeah.
class drive
Yes.
already. I think I mean, fundamentally, it just comes down to needing to build systems that are more intelligent, more resilient, so
Yeah.
that we can eat a byte drive loss and not lose availability or whatever the QoS, the performance guarantee is in that particular system, right?
Yes. Yeah. So that's a great point, actually. So I think what has happened in the last, I think a decade, especially the CSPs, the hyperscalers, they are taking these large density drives. And you touched upon LC9, the 245 SKU that we announced. That was purposefully built for large scale repositories and data lakes. And the primary driver is rack consolidation and power efficiency, right? And so when you look at from a RAID rebuild, you mentioned blast radius and RAID rebuild. What hyperscalers are doing is, they are sharding the data. So the data is, very small chunks, and distributed across many storage devices. They are doing erasure coding across the racks. They are also now with smart monitoring, latency monitoring. There are so many tools for predictive analysis, so that before the drive goes bad, they decommission and replace the drive, so that they don't have to deal with the failure. And even the locations, they are separately located, and they can build. You can also build with multiple drives now, instead of rebuilding just through few drives, right? So in general, you are actually accelerating the rebuild times. And if you compare today's, say, 30 terabyte HDD versus a 245 terabyte SSD, so I can, it's even at Gen 4 speeds, right? Your read speeds are 7,000 megabytes a second. So you could build a 245 roughly in, say, 1.5 hours, versus a 30 terabyte hard disk drive will take about 5 hours. So not only you have six times the capacity, you are almost four times faster, three and a half times. So you're almost 20x faster in rebuild times also. So yes, there is obviously a concern, and I think the other way to think about it is 2 terabyte drive. If I'm giving you 5 year warranty and 2.5 million MTBF for a 2 terabyte drive, and same for 245 terabyte. From a reliability point of view, you are still getting the same reliability underneath. So, on top of having all of these provisions, I think now the blast radius concerns have kind of significantly come down. But for OEMs, as we touched upon earlier, there may be some concerns for point of sale and stuff like that. But in general, I think at least at a large deployments, it's much better handled.
So speaking of large deployments, you hit on liquid cooling a couple times, and I want to visit that because we're seeing that in a number of different ways. But uh, I suppose the NVL72 or the GB300 nodes now are really what's pushing that from the AI training perspective at a large scale with the E1S drives. What are you seeing there that's interesting, or what do you have to do as KIOXIA to be ready for big shifts like that in technology?
Yeah, so we have been participating in the standards, which is the SNIA SFF was driving that. And so we've provided some comments to improve certain things. But primarily, the idea is to have is secondary and primary sides, and the top and the bottom, which are the thinner sides of the E1.S. And the idea is to have one side cold plate from the host,
Mhm.
and you change there are minor changes so that we have the right connection for thermal conductivity, right? So in that regards, there are changes in the the material, the tooling. You need certain flatness and roughness, and some of the customers wanted like a chamfer around the connector. Some customers may use TIM material, some customers may not use TIM material. So we kind of helped the industry, and tried to say, hey, there are certain things we need to kind of do it this way. But otherwise, I think we will be ready we'll start with Gen 5 drives and then go to Gen 6, because, the Gen 5 will be our POC. Like, hey, whoever is deploying Gen 5, even in Gen 6, because some customers are going liquid cooled, whether it's Gen 5 or Gen 6, it's like, whatever drive, it has to be liquid cooled. So So we will start with Gen 5 and then move to Gen 6.
Okay. So that, I mean, that makes sense for the big training systems, of course. If we can get fans out of those, get those to be more efficient. We all know the reports of how much power AI is consuming these days. And I think it's generally, by most sort of underappreciated how much electricity, obviously the GPUs, but the fans to cool the GPUs and to cool the system use up a tremendous amount of power. So there should be some good savings there. Do you see that as you look down the road translating to the enterprise market? Obviously, we've seen systems from Dell and HPE and Lenovo and Supermicro. They're all using liquid cooling to different extents, but the enterprise is just a little more reluctant than
Yes.
most that are putting in these training clusters to rework their data center and bring in water. In some cases, they can't do it. Others, they
Yeah.
don't want to do it. Um, but it seems like for next gen systems, we might be getting so close to the benefits of fully liquid cooling these systems from a power consumption standpoint that it may just tip the balance. What do you see in the enterprise world?
Yeah, that is very true observation, Brian. What we are seeing is, especially on the Even.S, most of the companies are following the NVIDIA direction and going with this liquid cool design on Even.S. But on the OEM front, where they are using external boxes, E3S takes precedent, and now we are talking about E3S because the connector can go much higher in terms of it allows for a lot more power. Especially with Gen 6, we would need more power than 25 watts if you want to saturate certain corners, and especially on the right side. So therefore, they are looking at liquid cooling on the E3S side as well, and that's also being discussed. So in the industry overall, I think that's going to be a de facto standard going forward.
Yeah, I think OCP has a couple working groups for liquid cooling, both direct to plate and then a separate whole chain for immersion, which is another place we've spent a lot of time. But the storage impact there is a totally different set of concerns,
Yeah,
which is interesting in its own right. Uh, those working groups must be fun to be part of too, because we're just in this shift in data center technology that's so dramatic that really we haven't seen this
that is correct.
in a very long time, maybe even since Flash first came into the data center.
I agree. AI is basically changing a lot of things that we had, and and an incredible pace also. Right, this is as you said, unprecedented pace that we are picking up, and things are changing so rapidly. But what we have, at least on the AI side of things, from a storage perspective, right? When you look at AI workflows and AI infrastructure, we feel that two vectors will be dominating for storage. One is capacity, and one is performance.
Mhm.
And capacity is where we basically announced the 245 terabyte first 245 or and that we did with 2 terabit first 2 terabit QLC die with an innovative 32 die stack on the NAND. So that's everything is first time, right? We never built 32 die stack. We never built a 2 terabit die. We never built a 245 terabyte drive. We never built an E3L form factor. Uh, so there's a lot of changes coming very rapidly at us, yes. And now, compounded with PCIe interfaces, the cadence is much faster because of GPUs.
Well, and it's kind of fun too because the storage really isn't the bottleneck anymore. I mean, there's different ways to look at it within the GPU system, whether it's a traditional rack server or those NVL nodes. The storage is typically fast enough to keep up with the GPU's ability to process data. But when we look at some of these real dense boxes, we're doing some work on a system now with 24 drives, 4 lanes. The ability to generate 250, 280 gig a second in that box is that's stunning in itself.
Yes.
But now, if we want to take that box and share it out to 6 or 8 or 10 GPU servers, now we got a problem.
Yeah,
problem, sort of, right? In that we can only go as fast as the network will let us go. I mean, the storage boxes have gotten very, very good,
that's
and
true.
the drives inside, and now it's a fabric issue of how many NICs can we get into this box to share it to all these hungry servers. Um, Data transport's not really your problem, but what do you view? What's your view on fabric these days?
Yeah, I think you hit it on the nail there. It's so for all, if you look at all the large deployments where all the money is being spent, right? They are spending a lot of money to kind of solve that problem also, because every bottleneck, right? Once is GPU, then HBM, then storage, then everything down the pipeline has to kind of meet the requirements, and therefore that is why the scale of money and amount of dollars being spent, capex and even opex, right? This huge. We've never seen this kind of investment overall in the data center at this rapid scale, at this scale and this speed.
Mhm.
And so I think that is being solved. And if you see the Ethernet guys are coming out with 800 native, and so on. And the smart NICs are getting much smarter, faster. CX8, CX9, NVIDIA is coming out with all those. So when you look at it, I think from a big picture point of view, that is being solved. From a smaller customers, yes, that is a challenge, right? So how do you scale? And now you have to make sure that the cost is also balanced, right? So 100 gig, 200 gigs, maybe 400. So I see it solved at a grand scale, but I think there will be a lot of like middle tier and lower tier that still needs to kind of come up to that, and I don't think we are there yet. So that's a challenge.
Yeah, I mean, AI is obviously driving that, but the good old fiber channel networks are still
Yeah,
going to exist, and we're still going to have like, databases. Can you
yeah,
imagine that? I mean,
yeah.
this is about the longest I've ever gone without talking about database performance. I assume you still have customers that care about that.
Yes, yes, yeah. I mean, especially vector databases, right?
Okay, you had to bring it back to AI, huh?
Well, no, I know what you mean, but yeah,
Yeah. Well, so there's another thing that I think is interesting about Kioxia, and this may be a hair outside of your wheelhouse, but you guys are doing a lot in software too, and open sourcing some projects. And I'm not sure the industry really knows that much about what you're doing on the software side. Again, I
Mm.
know it's probably a little outside your scope, but just give us some of the high level beats on your view of software and some of the open source work you guys are doing.
Yeah. So, couple of things. So our there is a group called Storage Pathfinding Group, and so we have a senior fellow Rory Bolt who's managing that group, and he was in the software side of things before, also in KIOXIA when we had the software defined storage. And primarily right now we are focusing on Isaac. You may have seen the demos and or some videos where what we are trying to do is what can we achieve in terms of performance without the DRAM required? How can we reduce the cost of the expensive HBM? And so Microsoft had Disk ANN, which was a software which would utilize this. And what we did was we took that and added our own recipe to reduce that significantly. So now, I don't remember the numbers on top of my head, but basically, Isaac is reducing the DRAM to almost bare bones and still get the same performance. There are minor things that may come up in terms of latency, but otherwise it's significantly improved. And so that's a huge cost savings for the customers.
Yeah, and you've got some, I think, some RocksDB work too, or something else that's kind of interesting. Uh,
Right.
but it does, sort of highlight how you guys are taking a multifaceted
Yes.
view toward, whatever the problems are you're helping customers solve. And then there's the whole fab side. So you're headed over to Japan, I think you said, and
Yes.
that's got to be pretty thrilling to be able to see those fabs and the wafers rolling off the line.
Yes. Yes.
Do they let you in there at all?
I have been to Yokkaichi before. This time, no, mostly I go for strategic discussions and mostly for the product roadmap and strategy discussions. But yeah, I don't plan to go this time. But yes, it's fascinating to see those wafers. And we have Kitakami, which we announced with SanDisk recently, where K2 is also ready for production. So yeah, we are growing and we are very excited.
Talk about that piece of it for a moment, because I think there have been some concerns about supply. We went through the COVID cycle where supply got diminished, and then maybe came back and we overbuilt or overproduced, and now it feels like we're sort of in an in between.
Yeah.
For plenty of people tell me that supplies are maybe even a year out at this point for large orders, for some vendors anyway. I don't know, but what is going on with supply, and what can customers expect, at least from your perspective?
Yeah, that's $1 million question right now.
It's
So
more
we
than that.
$1 billion question maybe. Yeah, so we talk to the analysts, we talk to the customers, we talk to the suppliers, and the shortage is real. We all see it. And what's happening in the industry is, as you said, when COVID hit and there was a lot of inventory. It was a huge downturn for the industry, and as an industry, we lost $30 billion on the flash side, SSD side. So after that, and let me say that when we go to BiCS 8, BiCS 9, BiCS 10, as we ramp the technology, and similar for our competitors, as you scale the layers or reduce, the lithography, your cost of the capex is increasing very, very rapidly and huge. Like before, it was, it used to be 2 year NAND cycle. Now, this is changing rapidly, and also that just to keep up with that kind of speed and increase the capacity, reduce the cost. While it's a great opportunity for the storage industry, it's also, there is always that fear that, hey, what if the downturn comes again? And I feel that the storage industry will be cautious to kind of grow, but it will grow. The trajectory is upwards, but how much each vendor kind of can do more, and how much fab capacity do they have idle today, or can they increase anything in terms of ramping up the production? That has to be seen. But yes, it's going to be interesting to see how as a lot of analysts say that this is a super cycle. So compared to the regular standard cycle, this is a super cycle, and if we believe that, this could take maybe another 4 or 5 years. It could last for that, or more. I don't know, but not a typical 1.5 2 year cycle, right? In that case, yeah, it'll be interesting.
Yeah, it certainly feels like we're in something, a super cycle maybe, but with AI becoming more productive and more real for more organizations, the no one's going to delete data. So all we're going to do is keep creating data, keep stacking data, and then now we've got to figure out where to put it, what these new tiers, what we used to call data lakes. I mean, that's even shifting the way organizations are thinking about availability of data and where AI is run. I mean, we've even seen backup repositories being targets for running AI against them for non-critical, non-real time kind of things. But uh, wherever the data is, I think we might see some of the AI get pushed at the data. I mean, we've seen that already at Edge. I mean, how many smart cities, conversations have we had, right? Where it's getting more tech into the edge devices so that they more work in robotics, more work in other industries where even a little NPU or something can bring a lot of analysis and insight to data. But yeah, the slowing down the storage market, I don't see that at this point. I think it's a question of where is the spend going to go? What is the flash and hard drive spend, mix look like? And do we start to get closer with these big drives that we've been talking about to really disrupting the hard
Yeah.
drive market? I mean, I'm sure you'd like to. take a swing at that.
Yeah, yeah, definitely, most definitely. Actually, if you, I was just looking at 245 terabyte that we announced, right? And if you look at a 42U rack, you can fit about say 10 drives per U and 420 drives of 245, just for the calculation of how that will. So that's a 100 petabyte rack, 103 petabyte rack.
Mm.
If I take that and compare to today's 30 terabyte HDD, you would need 7 racks. And now you need the additional networking, the switches, everything. So if I compare, the biggest challenge, as you touched upon earlier, with all the GPUs and the power being a big constraint, what's happening is GPUs are taking more and more power. And Nvidia and others are, they want to cram more GPUs per box. Okay, so NVL72, 144. Now you're looking at bigger and bigger numbers, right?
Mhm.
Now the challenge is, power has to come from somewhere. The data center pipeline is fixed. So while you can build bigger data centers with more power and so on, what are you going to do about today's powers? And now you're also going to liquid cooling. So the power reduction could be a huge benefit if you go to SSDs, right? So in this case, right, where you have 42U, 100 petabyte rack and 7 racks of hard drives, IOPS per watt is almost 1300x.
Wow.
And while they are increasing, while HTTs are increasing to fit more spindles to get the capacity, now you're most likely 30 to say 40 and then 50. But even with 30 terabyte, your performance is not growing, right? So performance density is a huge problem. There's no scaling there. So IOPS per gigabyte, right? Even with 245, which is a huge denominator to have it in the at the bottom,
Yeah.
even that is still 600x better. And then your throughput is 7 to 8 times better. So overall TCO is huge improvement.
Yeah, we've seen those charts, right? And the efficiency numbers that you talk about, and just the raw growth of data. I think there for many that table will flip, and
Yeah.
there won't be any other choice. We talked a lot about OCP and hyperscalers driving the industry, but now we're coming up on sunny St. Louis and Supercompute 25, which is going to be an interesting one. I'm not sure St. Louis is ready for this. I went to the first supercompute after COVID that they had there, and it was okay, but it was only a couple thousand people. I've heard from dozens of people that have to stay 20 or 30 minutes away from the convention center. We're at 4 different hotels just for our organization. It's going to be wild, but people seem really excited for it. I'm sure you guys will have several people there as well. What do you look forward to from what the HPC world can teach us next in terms of where technology is going?
Yeah, that is very interesting. We did attend the last few supercomputing events. One was, I think, last time was Atlanta,
Hmm.
and this time it's St. Louis. So we will be there. And I think in most cases, especially in the supercomputing, we are there to listen. We are there to learn, especially with Cray and like the supercomputing giants, right? What are they doing, right? If you think about today, like compare it with 20 years ago, now you are having supercomputing in multiples of racks. Literally your GPUs are so powerful that now you're just like supercomputers all together. But we go to listen. We specifically we talk to the customers. We talk, attend the sessions and learn what the new technologies from a thermal point of view, cooling point of view, performance. What are the pain points, right? What are the solutions that they are bringing? So yeah, generally it's more of a absorbing things from the industry and see how we can help in the standards perspective, or say SSD feature or a performance point of view. But yeah, nothing specific, but mostly learning on all the stuff that is going around.
I mean, you've got, I don't know about all your customers, but most of your non-hyperscale customers will be there. All the server vendors, all the storage guys, the big ones, Weka and Vast and DDN and all those guys that are quite popular at shows
Yes.
like this. Because again, we're back to
Yeah.
some of the conversation we've already had, feeding these large clusters and scheduling time on them and scheduling access to data. I mean, there just becomes this orchestration
Yeah.
of data movement that becomes really important to this audience is what
Yes.
I expect we'll hear more of when
Yep.
that show comes up.
Agreed. Agreed. And yeah, I think that it is growing, as you said. The popularity is growing, and I see the OEM customers, and now I'm seeing hyperscale customers also having a big presence there.
Hmm.
So and rightly so, right? It's more of you've seen announcements from Google on the quantum computing. They even on the large language models. They last I think last month they announced that they hit quadrillion tokens in a month. So which is this kind of scale requires new, because there are also, if even if from supercomputing, I think there is a chance to kind of derive something goodness in your standard computing also. So there's also that hope that it kind of intermingles. Yeah.
Well, that's why I like personally OCP and supercompute so much because you get a vision into where the enterprise will end up. You know, we
Yeah.
we'd like to think, I think that the OEMs have a lot of discretion in the systems they build. They
Definitely.
do, of course, but it is so greatly influenced by what's happening
I agree.
outside that world and at the hyperscalers. Even things like form factor. I mean, 21-inch servers
Oh
are
yeah.
the OCP standard now, and things like bus bar and like there's all this other technology that will start to feed into the way enterprise servers are designed and really make data center designers and IT admins and everyone that's involved in the acquisition process of any of these systems has got to be juggling so many balls and thinking about so many different challenges. It is not as simple as it used to be, and it will continue to be, a big diversity in technology. I think, yeah.
Yes, completely agree. I attended OCP, and I don't know if you probably saw the Meta keynote,
Mhm.
and the VP, I think his name is Dan. He was explaining the they have that ORV3, the wide rack. So now they have the ORV3 wide, and now they're talking about even bigger racks, and they're talking about special, like, trolley and tools made for that rack, because there's nothing. This is like an elephant. It's like one big elephant. Just to move that thing around is also another challenge, right? And they are obviously doing through OCP. So this is like open source. You can do this. And you talked about bus bars. We are talking about this 800 volt,
Yeah.
800. It's just getting crazy, and everybody will benefit from that, as you said. When OEMs and hyperscales get together, it's kind of solving each other's problems together, hopefully, as an industry.
Yeah, well, I mean, ultimately, they're after infinite resiliency, right? And I think that's also important at the enterprise. We've talked about the nines forever, 5, 6, 7, all of the nines. So that's clearly the directive. Well, this has been fun. I appreciate you hopping in, and I think you have done a good job to articulate a lot of the benefits and things that you guys are working on, the 245, the software advancements, the some of the thoughts on liquid. I mean, these are all important topics that I think our audience will take great joy from getting your perspective. So thanks for that. I appreciate you hopping on today.
Oh, thank you, Brian. Thank you for having me. Pleasure's mine.